Good afternoon, everyone, and welcome to our webinar, Cambridge Science for WA Second Edition, supporting teachers to deliver the new WA curriculum. Presented by Brodie Reid and lead science publisher Sarah Fabris. My name is Nicole Donnelly, and I am the Education Sales Consultant for Cambridge, located in Perth. Before we get started, in the spirit of reconciliation, Cambridge University Press and Assessment acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respects to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people here today. Please welcome author Dr. Brodie Reid and lead publisher Sarah Fabris. Dr. Brodie Reid teaches secondary science and Year 11 and 12 ATAR chemistry. He also has many years of experience teaching at the tertiary level and is an author of over 10 academic publications. He has presented his research internationally, winning several awards along the way. Please submit your questions throughout the webinar, as we will have some dedicated time to answer these at the end. If we do run out of time, we will have these questions answered and responses sent.
Hello, welcome everyone. Thanks so much for joining us this afternoon. So my name is Sarah, I'm the lead publisher on this project, and I'm joined today by Brodie. So we're going to talk a little bit about some of the changes in the curriculum and also how we're supporting it with our new resource that we're bringing out. So the agenda for today of what we're going to talk through, first of all, Brodie's going to take you through some of the key curriculum changes for the new WA curriculum that's being implemented next year in 2026. And then we'll go through some examples of how we're covering the curriculum throughout our new resource. And then I'll also at the end just take you through some of the time-saving tools and features that we've got particularly in our digital resources for teachers. That we're really excited about, that should help a lot with the new curriculum and the changes that will be in that. And we'll finish up at the end with a Q&A session. So before we go into the books, I'll hand over to Brodie Reid, our lead author, to take you through some of the changes in the curriculum.
Thanks, Sarah. All right, so I guess just to begin with, I'm sure most of you might be across some of the changes that are coming in next year and familiarising yourself with them. So really here, I'm just going to go through summarise what some of those changes are across year 7, 8, 9 and 10. I guess the key thing, here are some of the key changes. One being that each curriculum dot point is now a little bit more clear in terms of the content that's actually being presented. In the old curriculum, there were a lot more generalised, and so it was left up to teachers to really decide what would be covered. Here, there's more specific examples as well. So in particular, there's a lot more Western Australian examples, particularly across, let's say, mining and space in year 7, 8 and 10, but also in biological diversity in year 9. We've noted that there are specific West Australian examples really across year 7, 8, 9 and 10, across the biological, earth and space, physics and chemical sciences. In particular, a few things. Science as a human endeavour is no longer one of the strands. It's now just been incorporated in the science inquiry strand as collaborating and applying. However, the science as a human endeavour content is still there. It's just been moved, and examples have been slightly changed in WA. Moreover, what used to be elaborations are now examples, and we have noted that the examples are not mandated. We don't need to teach the examples. However, in our texts, we've tried to hit all of those examples just to give teachers the wide variety, teachers and students, the wide variety of Western Australian examples in particular to refer to. And we do note as well, there's plenty of Aboriginal and Torres Strait Islander people's focuses in the examples, some that have remained from the previous curriculum, but even some new ones for the new WA curriculum. In year 7, I guess the few things that we've particularly noticed is there has been some added content in the earth and space sciences around celestial objects, that being things like planets and meteorites being added to the content that was already there, which was Earth's rotation, seasons, eclipses, and moon phases. So that's been added. Most of you will already know that States of Matter has now moved from year 8 to year 7. It's quite a nice change, and I think some teachers will have already been teaching this in year 7 as well, because it does sit nicely before you get into separation of mixtures. It's nice for the kids to know about solids, liquids, and gases. And we have just noted that some of the water cycle stuff that was taught in year 7 has been moved to the primary years, though we do touch on it later in year 9 in a bit more depth. And the renewable and non-renewable resource content, I guess, has just been spread out into examples across year 7, 8, 9, and 10, rather than having its own specific content in year 7. In year 8, one of the larger changes in the WA curriculum was the movement of plate tectonics to from year 9 to year 8 to marry up better with the rock cycle, so that the two can be presented more closely together. Though the rock cycle content has also been expanded to include more of that mining and mineral physical properties content contextualized to Western Australia. So it does fit quite nicely overall in the new text. In year 9, this is probably where, well, as you can see from the screen, where most of the key changes have occurred, being one of our middle years between year 7 and 10. In year 9, there has been added content into the ecosystems or that ecology content based on population size, sampling, and biodiversity. Just some extra content added there. In the chemical sciences, there has been added more specific, more explicit content on naming and writing chemical formulae for ionic and covalent compounds. A lot of teachers might have already been doing this, and it is noted in the curriculum that it's now just more explicit. Teachers were likely doing it already. It's now just more explicit. In physics, there's still light and sound waves, and while some teachers might have already been teaching reflection and refraction of light, this has now become explicit in the curriculum dot point as well. More content has been added as well. So, for example, in year 10, from year 10, the models of the atom, and I guess more detailed. A lot of teachers will already teach the models of the atom in year 9, but just more details have been added to year 9, as well as any history of the periodic table or how the periodic table is constructed. That has all been moved down to year 9 as well. And then a key change, given that plate tectonics had moved from year 9 to year 8, the Earth and Space Sciences have picked up climate change, global systems, the carbon cycle, and even the water cycle in there. And then finally, year 10, one of the key changes is the inclusion of models of chemical bonding, including ionic and covalent molecular bonds. And that includes obviously the writing of formula and the writing of the names for covalent compounds and ionic compounds in particular. And then in the Earth and Space Sciences, there is an elaboration into space exploration. There's already content on the universe and the Big Bang, but more WA contextualization as well there. So a slight extension in the content in the new curriculum. Overall, the science inquiries strand has obviously incorporated the old science as a human endeavour content, and it's now just called science inquiry, so no longer science inquiry skills. We've noted that. And in our text, we cover every single example that's in the science inquiry strand, including those science as a human endeavour dot points, but also we cover all the examples that are across the science understanding content as well. So just so that everyone is able to see what's being covered in each of our new texts, in Year 7 Science, here's the table of contents. In particular, I'll just note that States of Matter is now there is chapter 4 just before the chapter on mixtures. As I mentioned previously, it does fit really nicely because when you separate mixtures, it is helpful to know about the states of matter, solids, liquids, and gases. So that's Year 7. in Year 8, you'll note that we have expanded the rocks and chapter to include rocks and minerals, and our Changing Earth includes that plate tectonics content. Moving to Year 9, I guess the key change in this text is the addition of Chapter 5, which is periodic table and forming compounds. So a lot more content in there to guide teachers and students on the history of the periodic table, as well as writing the names and the chemical formulae for compounds. And then in Year 10, I will note as well that we do have a new chapter there, Chapter 4, Chemical Bonding. It used to be the periodic table in the first edition, though that's moved, and now we do cover the new content on covalent bonding and ionic bonding in there. And that is the table of contents for Science 10. I'll now throw over to Sarah to go through some of the content that we cover in the books.
Perfect. Thanks, Brody. All right, so we'll just go into a little bit of examples about how we're actually covering this in the syllabus. So in Year 9, and this is some content that I'm pretty excited about, is the new parts that we're covering on specific ecosystems in WA. So in Year 9, we've got the new content descriptors on adaptations and animal survival, plant and animal survival in their environment. So you can see some examples we've got here. This one has some specific examples about ecosystems in WA, including deserts and mangroves. So we've covered all of that explicitly in the text, but there's also accompanying activities of all different types that are covered through that. So I think we've got one more example from Year 9 biology as well. So in this case, the curriculum itself is not WA specific, but the context we've covered it in, we've tried to use WA examples wherever we can to keep it relevant and tailored to the students that are reading it. So you can see here where we've talked about the different regulation of temperature in organisms. You can see we've got native WA animals all throughout this. And I will say actually as well that our other author, Gemma Dale, on this series did a really fantastic job of finding these local and specific examples. Gemma actually has a background in ecology as well. So this was something that she's really shown through in putting this together as well. So some other examples we had was in the Earth and Space Sciences. So where Brody mentioned that we've got the new space exploration content in the curriculum now. There is also an example attached to that descriptor about the Square Kilometre Array, which is definitely something in WA that we want to celebrate. It's a pretty exciting project. It's pretty prestigious for WA. So we thought this was a great opportunity to really let it shine and to focus a little bit of some investigation activities and other things around it in the text for the students. So you can see a little bit of it just there in the Year 10 book. And then I think I'll just throw back to Brody to take you through some of the chemistry content as well.
Yeah, thanks, Sarah. I did want to highlight here that because we are, I guess, moving into a bit more of the covalent compound bonding and the ionic bonding, we've really tried to make this as easy as possible for teachers and students to conceptualize. And so, for example, in Year 9, introducing the covalent bonding model, we're not going really too far in depth. We're just really highlighting that it's non-metals. Here are their electron shell diagrams and showing that it's a formal sharing of electrons. So we're using these types of diagrams as much as possible to make it as easy as possible for students to access that content. And then I'll show you an example from Year 10 where this is more the explicit teaching of how to write ionic formula of ionic compounds. Many of you will teach students the drop and swap method. Here's a worked example showing them that type of thing. Although in the text, it is, I guess the content is given, in terms of a 3- charge requires 3 of the positive charges. However, this type of worked example is also helpful for students just to get their head around combining ions. So this was not explicitly in the old curriculum, but now it is, and a lot of teachers will have already been teaching this type of content. So there's plenty of worked examples to really walk the students through how to master these skills prior to their further studies in chemistry. And what's really exciting as well, and a lot of teachers have asked for this type of content to be explored as well, and that is we do have a section in the book on I guess, extension work, which is chemistry calculations. So for those students that are ready for it, there's a section where we cover the calculation of moles, molar mass, and number of particles, and with plenty of worked examples. So here's one worked example that shows how to work through the calculation of a few different types of questions. This is not part of the new curriculum, though we are excited to be able to share that with schools that are using our textbook. I'll send back to you, Sarah.
Thanks, Brodie. Yeah, and it is really exciting having the extension content in there, particularly now that the curriculum is bringing down some of that really complex chemistry content from higher year levels into 9 and 10. So I think it'll flow really well on from that. So I just wanted to take you through, now that we've been through all of the understanding, just a little bit about the science inquiry strand. And I guess even though the structure is very similar, we put a lot of effort in our new edition into really covering this in a way that aligns with best practice and that makes sense for students to step through in a step-by-step way. And so just as some examples here, this is from our Year 7 text for the Year 7 and 8, because it's banded in the skills curriculum, the Year 7 and 8 questioning and predicting strand. This part flows through using very, very similar or the same examples to step through different processes in the scientific method and through the inquiry skills that they're having to learn. We keep that consistent in Year 7 and in Year 8 so that students have that scaffolding as they step through. I think also in planning and conducting in Year 7, I think we've got another slide just with a practical just to emphasize that. So this one, this particular prac, actually, there's a few like this where we've got much shorter and simpler pracs for students which are focused just on the skills that they need to learn. Obviously, this is much more relevant to Year 7 and 8, and they appear in Year 7 and 8 much more. So some of these pracs don't have so much detail on writing a conclusion or a practical report or even writing up results. It's just practicing these really essential skills towards the start of the term that they need to know. You'll see in this one as well that there's a video icon in that prac. So we do also have practical videos for some of the pracs. These videos are particularly for the technical pracs, so particularly chemistry ones with that new content coming down, and also some of these skills pracs that aren't specific to a content area. Essentially, the videos are just designed to walk the students step by step through the prac. So they can do that if they're going to be absent that day, or if you'd like them to just watch the process of how to put things together before they come in for their prac day, just to get them ready for how these things work. The part of the book where this prac is introduced as well includes all of the safety and the risks and everything like that around Bunsen burners and around all of the other stuff that's in the curriculum. You can see here the descriptor about managing risks. So that's all kind of covered continuously in the same section of Year 7 and similarly in Year 8. So as we move down through the inquiry section, we've also got processing, modelling and analysing. I think there was one thing that was noted was that they've changed the wording to be modelling to make that more of an emphasis on that as well, which is really great to see. I think that's something everyone's been doing as teachers, has been including a lot about modelling in science. It's an integral part of it, but it's nice to see it just being called out now. This part, I just wanted to flag that even though we cover the processing, analysing skills throughout our science inquiry chapters at the start of each chapter, we actually also include these dedicated data question sets at the end of every chapter. So this is essentially particularly aligns to that second content descriptor you can see there on the slide about analysing and connecting a variety of data and information. So these data questions essentially give them practice in doing that, but in the context of the science understanding chapters and topics that they're going through. And so in the classification chapter, for example, you'll see one about classifying organisms. In these examples on the screen, there's one about chemistry, and you can see one from our universe chapter in Year 10 is interpreting a Hertzsprung-Russell diagram. So it's all in context, but it reinforces those skills that there is necessary for them throughout. So if we just go through, I think we have one more for science inquiry. So for Year 7 and 8, Something we've also added to this edition is through the whole process of all of the inquiry skills they have to learn, we've tried to scaffold this a lot more and a lot more explicitly in the book. So for example, we've got these annotated practical reports in Year 7. We've got a few similar things in Year 8 and even in Year 9, where we just have specific sections where we talk them through how to write your conclusion, for example, how to write up a results table, how the discussion actually works, what the point of it is, how to identify errors, all of that sort of stuff. There's a lot more scaffolded support in both the print books and the digital. So it's there no matter how you're using the resource for the students. Okay, so now I'm just going to take you through some of the exciting stuff that we've been working on that Brodie, Gemma and I and the rest of the team have put together. So I suppose with this resource, when we spoke to teachers to understand what they needed and what they wanted in a resource, was the biggest thing was something to save time. Everyone, and I'm sure all of you here this afternoon don't need me to tell you that teachers' biggest challenge is one of the things that always comes up for us is time. Everyone needs more time. And so that was essentially what we focused on with how we put all of these resources together, so that essentially lessons can be planned in a way that everything is done as much as possible. And everything's already there, ready to go. So one of the key things, as you see here, is that everything is downloadable and editable. We also include separate versions with answers. So this was a key thing that people had asked of us, is that they want to have the version with answers they can access easily, but also the version that's already ready to just be printed and given to a student without the answers, so that they can do worksheets or chapter tests or whatever it is they're working on, and the teacher's not having to kind of manually delete answers or anything like that. So you can see here just how a little snapshot of what that looks like in our teacher resource. So this is within the online teaching suite. There's actually just a zip file you can download that has all of the answers available. So this example is for chapter tests, but it's also the same for worksheets and things like that. Practicals can all be downloaded as downloadable PDFs. They can be edited, everything like that. So we've just tried to make everything as flexible as possible so it can be customized as it needs to. We've also got, for example, worksheets. So this is a Year 7 versus a Year 10 worksheet. You'll also see with all of the formatted worksheets that are just ready to print out, these are all actually very carefully leveled as well, so that if you do need to differentiate your students in real time, you can give them some pointers, like, for example, just answer questions 1, 2, and 4 or whatever. These little graph icons you can see beside each question actually specify to you what level each question is in the worksheets and in the chapter tests. So it's just a really subtle way to kind of indicate, you know, if a question's quite challenging. If you've got a student that's struggling and you don't want them looking at the really challenging stuff yet, you can just focus them on that kind of lower order thinking and the easier questions. So in these examples, you can see in the Year 7 sheet, those 2 questions about graphing data are easy questions. And in the Year 10 one, you can see question 1 is easy and question 2 and 3 are in that middle range, so slightly higher order thinking. So that's all been done for you. That's all completely leveled out. The leveling is also appears in our online test generator. So you can filter by levels 1, 2, and 3, and then create tests as you need to at different levels if you need to vary that for your students. The other thing, we have teaching programs to make lesson planning as easy as possible. So these list out the time required for each lesson, all of the resources that we have for both the students and the teachers in the digital resources. So that's all provided in Word documents so that you can edit that as you need to. We do acknowledge we provide a lot of resources and we don't expect teachers to need to use every single thing we supply, but we just cover all of the examples in the curriculum. We'll provide activities on all of it so that you can pick and choose what you want to cover and how you want to cover those descriptions. So the teaching programs can all be modified to kind of suit what you need. We've also got PowerPoint chapter summaries for each chapter. So these are presented in a way that they can just be projected and used for classes. Again, because it's in PowerPoint, it's editable, so you can change it, delete things as you need to. I think we've got an example there from Year 10. So it's a little bit of what they look like. So they'll always have the section heading at the top so you can see which part of the book that this is relating to, or the interactive textbook, depending on how you're using it. And we also, the way we've structured all of our books, and this is similar to the first edition, so it will be familiar to anyone who's already using our resources. We do have learning goals at the start of every section of every chapter. The learning goals, we've tried to make these a little bit more concise and simplified so that they are accessible to students. We all know literacy is quite a big challenge at the moment, so we want to be able to get the science across without literacy holding students back. So these have been formatted the same way. So you can see a print to digital textbook comparison there. So that's a view of the student interactive textbook for the same section that you're seeing there. So the print book, you'll also notice there's icons there to indicate if there's worksheets or videos that are relevant to the content. And they'll also appear in the digital resources. So the students can watch that video. It's got captions and everything. They can download worksheets as they need to. And the teacher has access to those versions with answers, as I said before. All of those learning goals at the start of each section as well, most importantly, are all collated at the end of the chapter in the form of success criteria. So this checklist can also be downloaded. You can access that on the interactive textbook as well. And all of the questions in the chapter review are linked directly to it so that students can just tick off as they go when they've hit their success criteria. That downloadable version that you can see, there's a little link to it on the screen. That will download a version that has a checkbox, so you can just print it out and give it to students so that they can check things off as they go. And then lastly, we also, something that's new to this edition that we're pretty excited about is our adaptive pre and post testing that we've created. So again, this is really, really useful for differentiation, but the most powerful thing about this is that it actually automatically adapts as your students answer questions. So this means you don't need to customize a different test for every student depending on their ability. You just assign in our learning management system the same test to every student, and it will show them different questions depending on how they answer. So there's a little simplified diagram here to kind of take you through that a little bit. So you can see on the left here, we've got level 1, 2, and 3. So the levels, it's obviously a simplified way of looking at it as just 1, 2, and 3. We are talking about that higher and lower order thinking. So every student in the first topic will start with a level 2 question. If they get that question wrong, the next question they see is the level 1 question in the same topic. So it gives them that extra opportunity to try and get the right answer, but at a lower level. If they get it right, then they're going to be shown the hardest question in that topic to see if they can really show that they're actually beyond what they were already being taught and that they already know. This is really powerful because it means that you're going to get really comprehensive results of exactly where each student is sitting without having to actually put any effort into how you customize that. So we really hope that this is going to save people a lot of time, that it's going to make this sort of thing much, much easier. A pre-test can be assigned before you start a topic or halfway through, the same way if you've used pre and post testing before, you can use it in that same way. And then the post test will show different questions in the same topic so that that removes that risk of students just kind of remembering a question from a few weeks ago and then answering the same. It's a different question, but it's exactly the same level and the same topic so that it's still assessing that same kind of success criteria. So you'll see so this is just a snapshot of what that reporting actually looks like in our learning management system. So you can see the color coding to show whether they've gotten them wrong, if they've got the medium right and the easy one wrong, etc. It shows you that for each student. And this view at the moment, so this is showing the view that aligns to our resources, to our textbooks. But you can toggle this to curriculum view as well. So obviously our books are aligned to the curriculum, so you can toggle between the two views and it will show the breakdown of topics within either a chapter or a content descriptor, whichever is the view that you're looking at the time. This can all be exported as well in Excel, whatever the other data thing is that we have. So just standard downloads that you can make if you want to add this to your school reporting as well. So I suppose the key things that we're hoping that you'll take away today is that we have tried to structure this to make lesson planning as easy as it can be. Obviously, there's some planning and some customization that every teacher will want to do for their students, and we would encourage that. We love the effort that teachers put into this kind of thing, but we do hope that we've made it as easy as possible and have simplified a lot of that admin work of the reporting, of customizing for differentiation, and for putting together printable resources. It's all there, it's all ready to go for you. We've got a huge range of activities, not just with all the different downloadable resources that I've just talked about. There's so many more in our print book as well. There's so many investigation opportunities, both practicals in the lab, but also secondary source investigations, so researching online, classroom activities, at-home activities students can do. We'd be here all night if we tried to list through all of it. So yeah, we're really excited about it, and we do hope that you'll want to reach out with any more questions that you have. So I think we'll finish up there, and we'll go into questions. Thanks, everyone.
Okay, so thanks again, everyone, for joining us tonight. We've just got to the Q&A session now. So I'm just having a look at some of the questions you've been sending through. Now, there's lots of questions coming through about digital features. I'm just going to start on the curriculum and the content questions first, because we covered that first in the presentation, then we'll get to the digital ones at the end. So we've got one question here from Joshua asking about Noongar language and asking if we've added Noongar language to most of the chapters in the text. So first of all, I'd say yes, we have made an effort to add some of this stuff in. We also, it's not necessarily all Noongar language groups that we've covered. We've also touched on other Aboriginal groups within Western Australia. But yeah, we've definitely put an effort into putting that in. We've also noticed the curriculum has included a little bit more of that too, which has given us an opportunity to really explore it. Brodie, did you want to elaborate on that a little bit?
Yeah, I can do a little bit. I guess what you said, Sarah, is exactly right. So we've tried to use in our Aboriginal perspectives as much Noongar language as possible. But also we recognise WA is a big state, and so we've tried to hit perspectives from other nations as well, like Yamaji, for example. But even so, I mean, in every chapter, if there was an opportunity for us to go beyond the WA curriculum to give an Aboriginal and Torres Strait Islander perspective, we've done that. So one that I'd note is in physics, we've got a box there on David Unipin and his discovery of the boomerang, I guess, or how the boomerang moves to actually relate to how a helicopter can hover. So while he's not exactly a WA example, coming from South Australia, I believe, we've just tried to incorporate as much as possible in that space.
Yeah, thanks, Brodie. And I will add to that too, just more generally on the inclusion of Aboriginal people's sciences as well. We've had a lot of feedback from teachers that it can be quite tricky to teach this content when they don't have familiarity with the cultures and the peoples that they're talking about, and that this can cause a lot of anxiety teaching this with students, which is understandable. So I will just mention too that we do have a Torres Strait Islander woman that's helped us add some really specific research and links and things like that to the teacher resources for this that aligns to the books. So this lovely young lady has actually worked as a research officer in a few different areas as well, working with remote Aboriginal communities. So she's got a lot of experience in understanding where to actually get that knowledge directly from the people that have ownership of it, rather than directing students to just search for things online unscaffolded. We've actually provided these links as recommendations so that teachers can trust that they're sending students to reputable sources, because that can be quite tricky in the big wide world of the internet. So yeah, it's definitely something that we've focused on with this edition. So just sticking with the content questions and the curriculum. So I noticed, so someone's asked a question about, is there a document that maps what content descriptors have moved? I'm assuming that's specific to the curriculum itself and not necessarily our books. But I'd say the best place to go for that is to the SCSA website and to check their familiarization documents. I think, Brodie, you would have referred to those summary documents in that first part of your presentation as well.
Yeah, exactly. So on the SCASA website, there's the larger document, which has the curriculum for familiarization, but they do also have, I think it's a 2-page document that just summarizes all of those changes and where things have moved. So I think that's, yeah, if you want the short version, that would be the best place to go.
Yeah, definitely. And so there was another question about forward planning and whether or not we have unit plans or planning documents that map to the textbook. So I can answer that one. So yes, we do actually do a comprehensive curriculum mapping grid for each of our year levels. So this is provided in the online teaching suite. In addition to that, we do actually do a full teaching program for each chapter. I think I would have just mentioned it in the presentation, but this basically sets out pretty much all of the features that we have. So whether it's worksheets or activities in the print book, practicals, anything like that, it's all listed in that program in sequential order and then divided into lessons based on the time it would take. So that's all there. If you do need access to any of that ahead of time, ahead of the products going live, you can definitely reach out to our sales reps and they can provide samples of that for you so that you can get an idea of what's in the books. So that's all definitely available for you as well. All right, just skimming through the questions again. So someone's asking if the book covers all examples and does that include collaborating and applying examples? So for example, Fiona Wood in year 8. Yes, definitely it does. I think Brodie would agree. So yeah, we have covered all of the examples. The collaborating and applying content that looks just like what Science as a Human Endeavour used to be. We've covered that similarly to how we previously did. So it's integrated with the content in context. So for example, Fiona Wood in year 8, yes, that's covered in the context of the biology chapters where it's relevant. I don't know if there's any other examples you can think of, Brodie, but yeah, it's essentially all throughout.
Yeah, no, nothing more from me. Just we've covered every single example and then plus more in the WA context as well.
Yeah, definitely. Okay. So there was one about practicals as well. So someone asking if the practicals are in the book or only digital. So yes, they are actually in the book as well. So when I mentioned that practicals are downloadable and editable, we're talking about the versions that are in the book. They also appear as a separate document for each practical in the interactive textbook. So we just provide them in 2 formats because we know some schools might like to bring the textbook into the lab, to do their pracs. But then you can also just print them out individually to give to students if you need to, or if you want to print all of them out and bundle them into a prac book as well, then I know some people are doing that with our resources as well. So this one on risk assessments is related. So just asking if we do risk assessments for our pracs. So yes, we do. So we will also have a downloadable risk assessment for each prac. That will sit in the teacher resources as well. So that's in the online teaching suite. Again, it'll be a downloadable file that's a Word document, so that it means you can edit it, or if you need to, you can copy and paste our risk assessments into your own templates if you've got specific requirements for your school, or if your lab tech has a certain way that they like to do it, they can sort of grab the content out and hopefully that'll save a little bit of time. Okay, what else have we got? So the science inquiry content year 7 and 8 is year 7 and 8 the same textbook content, and is it the same for 9 and 10? Yeah, okay, so Joshua, thanks for asking that. So I believe you're probably referring to the part of the presentation where we talked about those banded parts of the science inquiry curriculum. So you'll see when I was referring to the year 7 and 8 content and then having examples from the book, I should clarify that our year 7, 8, 9, and 10 skills chapters are completely different from one another. So we don't just repeat the content from year 7 to year 8. It is completely different content. So for example, that Bunsen burner prac only appears in year 7, not in year 8. I think what we wanted to emphasize is that we do cover the same skills throughout, and we sort of build on them gradually as you go up. So it sort of becomes less and less scaffolded. A really specific example of that actually is throughout the book where we have our practicals. Whenever there's a conclusion where it's asking students to write a conclusion, it'll follow that really scaffolded version for year 7s where it says fill in the blanks that say from this experiment we can claim XYZ. And then as they go up through the year levels, it's a bit less scaffolded and it just becomes write a conclusion that states your aim, summarizes your observations, and supports or refutes your hypothesis. So we go through that in a scaffolded way. You'll know if anyone attended the SCSA webinars tonight or yesterday, you'll know that they noted the inquiry skills. There's certain things you don't need to know in year 7 and 8 now, like a hypothesis. That's more year 9 and 10. I think another one was validity is year 9 and 10, but not year 7 and 8. And so we've woven in those changes as well with the scaffolding. And the other thing to note is there are different examples under those banded descriptors for science inquiry. So each year level has their own examples, and we've covered them in each book as well. Not necessarily in our inquiry chapter. Some of them are relevant to the specific content. So there might be an inquiry question about expansion and contraction, and then you would see that appear in a prac in the States of Matter chapter in year 7, for example.
I'll just add something in there, Sarah. Yeah, everything you've said was great. And then I just wanted to clarify with, so we still use the word hypothesis in year 7 and 8, but it's far more scaffolded for them. So it's really aligned. It is aligned with the curriculum, but we just give them that little bit more scaffolding towards what they would need to know in the future. Similarly with validity, we start in year 7 calling it, what is a fair test? But then we do relate that fair test idea to validity, and all the way up until year 10, where it's really, validity without actually scaffolding with that fair test idea.
Yeah, it's a really good point, Brodie. And I think we do think it's important to kind of introduce these terms as early as we can. One thing we sort of do with that scaffolding is we might introduce some terms, of course, like hypothesis to a year 7, but we're not going to put all throughout our chapter tests all of these assessment questions about hypothesis, because we know that they don't really necessarily need to demonstrate their understanding of that at that level. So you'll notice, for example, in our learning goals, they'll be quite closely aligned to those curriculum points. So in year 7 and 8, for example, there'll be a learning goal in the inquiry chapter around forming questions or investigable questions and making predictions, whereas once you get to year 9 and 10, it's more about forming hypotheses. So there's just those sort of subtle differences, and like Brodie said, to kind of do that scaffolding throughout. So there was a question here as well. I've just said learning goals, and I've just seen a question about learning goals, so that worked well. So someone's mentioned the learning goals and the PowerPoints as well. Yes, so the PowerPoints, each time you get to a new section in that summary, there's one slide that lists the learning goals for that section. So yes, they are definitely included there. Okay. There was one about the pretests. Are the pretests downloadable? And is year 7 pretest aligned with primary school content? Yeah, so the great question, Joshua. So the pretests are not downloadable. They are one of our main assessment features that's entirely online. The downloadable versions that are the most similar would be our chapter tests. So we do have structured chapter tests with multiple choice, short answer and long answer with comprehensive marking criteria and answers at the end. That is definitely downloadable, but yeah, these diagnostic tests aren't currently. They probably unlikely to be, because they are very much designed to be used in that adaptive way that kind of only works in an online setting. But yes, with the other part of your question, are they aligned to primary school content? So yeah, the year 7 tests definitely are. Even some of the year 8 tests end up having primary school prior knowledge, because it just depends on when was the last time they saw that topic. So typically, for example, year 7 classification, there might be prior knowledge on adaptations in grade 4 or 5. Now that the curriculum's changed, I might be wrong, but it gives you an idea of kind of where that comes from. In the chemistry chapters, some of it comes from year 6, some of it comes all the way down from year 4, just so that we can find that meaningful link of where they've last learned that topic. Because it's not really accurate if we were to source it from just the immediately previous year level, if they haven't covered those topics in school that year, because it will give you slightly inaccurate results in terms of what people understand. So yeah, I hope that answers your question, Joshua. Okay, so there was another one about science inquiry. So are there resources for students to practice those science inquiry skills like variables, etc., in the context of scenarios appropriate for each chapter or subchapter in the text or just digital? Yeah, definitely. So I can say, and I'll pass to you to elaborate on this, Brodie, but yeah, we definitely cover it in the context of the chapters where they're relevant. I think some skills, all of us can probably reel off a few skills that we typically very traditionally teach with forces or with chemistry and that sort of thing. Brodie, did you want to elaborate on that one?
Yeah, I think in that science inquiry part of the new curriculum, there are actually examples of practicals that should be done to hit different parts of the science inquiry curriculum. So we have done all of those practicals, all of the examples that are there. So certainly throughout each of the different sciences, we've tried to embed those science inquiry skills throughout the planning, the method, and then the evaluation or discussion of the results. And then we've also got at a higher level, at the end of every chapter, we have, what is it called, Sarah? What did we call those? It's like
The STEM activities or
the STEM activities, that's right. So that just allows, a bit of more higher level thinking and problem solving and critically analysing situations in each chapter as well. And that's sort of hitting that, I guess, highest step of Bloom's taxonomy there. Did you want to say anything more about the STEM activities, Sarah?
Yeah, well, definitely. So we did actually, I was speaking to a teacher recently that does use our STEM activities regularly. And one thing that she mentioned to me was that she loves that not only that they're an opportunity kind of for collaboration, because they're very much group activities a lot of the time, but she actually said she uses them to get students to practice that whole process of creating something, evaluating if it works, and then when it doesn't work and everything falls apart, trying to figure out what went wrong and then coming up with new questions and new ideas from that. So not just problem solving, but just that, I mean, it's the scientific method in a nutshell really is, in evaluating what you've done and finding ways to improve it. And that's a lot of the questions that appear in the discussions in our pracs is, what sources of error did you have and how can you improve it in the future? So they're definitely great for that. I would definitely recommend using them where you can for, inquiry skills, scaffolding as well. Okay, I think we've almost covered off all of them. So there was one person actually that flagged, Leslie, thank you so much. So Leslie actually flagged there was an error in one of our samples. So thank you for flagging that. And I can confirm that since putting those slides together, I believe that error has already been fixed. So I do, just to reassure you that the pages are uncorrected at the moment. So they are still going through their rounds of editing. And we hope to have very polished proofs for you soon as well. So if anyone does want to see further samples than what you were shown in the presentation today, definitely reach out to Nicole or our other rep, Deborah. So Nicole's going to go through contact details once we finish up today. We're super excited to show you as much as we can because we've had a lot of fun putting it together. Brodie's done a fantastic job in planning this out, had some great ideas, and Gemma, our other author, has as well. So I'm really proud of what we've been able to put together, and do get in touch if you'd like to see more, or if you've got more questions after you leave the webinar tonight that you forgot to ask, then definitely send them through, get in touch with Nicole and Deborah. Any content questions you've got for me or Brodie, that will all come back to us if you get in contact with the reps. So they and us would love to hear from you. All right, I think that's about all we've got time for today. If we didn't get to any of your questions that you have already asked, we will get in touch with you afterwards as well. But other than that, I think I will hand back to Nicole to finish up. Thank you.
A big thank you to Brodie and Sarah for taking us through today's webinar. Before we go, I'd like to take a couple of minutes of your time to showcase the Cambridge's new science resources available in Term 3. These resources include an interactive textbook and an online teacher suite that will be available to adopting schools. These new resources are on the same platform as our maths resources that are being used in most schools in WA, making it a smooth transition for students and teachers alike. An interactive textbook is included with the print copy and includes the following features: concept videos and video demonstrations, including practical videos that walk students through the steps to prepare and execute a practical in class. Success criteria checklists at the end of each chapter. Workspaces in the interactive textbook allow students to enter their answers. Self-assessment tools allow students to check their answers. Auto-mark quizzes give students immediate feedback on their progress. Rollover definitions are available for key terms along with a full glossary. Downloadable worksheets provided for all section topics. Interactive widgets demonstrate a concept and are accompanied by a set of questions. Scorcher competition provides timed, quick quizzes at the end of every chapter and an offline textbook. The online teacher suite is available for schools who adopt Cambridge resources. We have a test generator that allows teachers to create customised tests from a bank of questions. All tests can be printed or assigned to students online for auto marking. The new adaptive testing offers ready-made tests with adaptive functionality and auto marking, enabling reports that provide evidence of students' progression. Task Manager directs students on a custom activity sequence based on their scores in measurable activities. Reports are available for students' results on quizzes and self-assessment scores. Teachers will also have access to the students' workspace to view and comment on student work. Downloadable chapter tests and answers are available for each chapter. Chapter summaries in the form of PowerPoint presentations are available for every chapter and can be edited. Teacher note icons are available throughout the online teacher suite, which will particularly support new teachers and teachers out of field. Downloadable tasks and assessments for practicals, review questions, section and data questions, quick checks and checklists. Planning documents and teaching programs will be provided. Downloadable worksheets for developing and understanding skills. Comprehensive solutions for all questions. And a new downloadable curated internet resource list for each chapter to find reliable information relating to Aboriginal and Torres Strait Islander peoples. Lastly, I would like to make mention of the upcoming Cambridge Science for WA event on the 14th of August at the Crown. Further details about this workshop will be provided shortly by invitation. I would like to finish off by providing my contact details and those of Deborah Wilson. Deborah is looking after WA's regional schools and I will be based in the metro area. We are both happy to arrange appointments to demonstrate the resources and answer any further questions you might have. Thank you once again for your time, everyone. You will receive a feedback form over the next few days. On completion, you will have the opportunity to indicate your preferred complimentary copy of the textbook. I hope you enjoyed this afternoon's webinar and I wish you all a lovely evening.